Now we will discuss about the superposition of two electromagnetic waves and especially light waves. So these are light. So suppose this is one wave and this is another wave. So this wave is coming like this and this wave is also coming like this, and these two sources, so this is one source, this is another source of light. So these light sources are monochromatic. Monochromatic means they are having same wavelength. We can say they are having same wavelength. But here one point is there, that if you say monochromatic, that does not mean that both are having exactly same wavelength, but 99% same wavelength. So that can be said as monochromatic. Even in monochromatic light also there is some variation of wavelength. But now we are not considering this, we are considering that wavelength are same. So if the wavelengths are same, but this distance travelled by both the waves are different. Say this wave has travelled a distance x1 and then it is superposed with another wave, and this wave has travelled a distance x2. And if I take here origin, so this is the point 0, 0, and this is my plus x-axis and this is minus x-axis. So these waves are coming from minus x-axis. So the eventually equation of the waves will be like this. So suppose this is wave 1 and this is wave 2 and they are superposing here. So the equation of the first wave we can write like this. So E1 is equal to E01 into cos omega 1t plus kx1. So see here, E01 is the peak amplitude, that is the amplitude, not peak amplitude, amplitude of this first wave. Amplitude means, so this will have an amplitude, so the amplitude will be perpendicular to this line, so perpendicular to this line will be like this. So this is suppose E1 and this wave is passing through this, so it's perpendicular, so this will be the wave, this will be the component E2, electric field component. So now E1 and E2 will make certainly some angle, but E1 and E2 are actually oscillating with very high frequency. So in this case, if we want to take the vector sum of these two, so vector sum of these two electric field components, so this will be the resultant. So this is not possible to take the vector sum of E1 and E2. Why this is not possible? There are two reasons. Number one is they are oscillating with very high frequencies. So the frequency of visible light is 10 to the power 14 Hz. So that much high. So 10 to the power 14. So they are oscillating with very high frequency. So at any instant, what is their magnitude? It is very difficult to find. And taking the resultant and the angle between them is very difficult. Number two, their size is extremely small. So we cannot. It is not like sound wave or mechanical wave that is having. I have drawn here big E1 and E2, but that doesn't mean that they are actually this big. They are very small, very minute. So you cannot take the resultant of this. So what can be done? We just take that at any instant the resultant is simply E1 plus E2. So we take simple summation instead of vector addition. So we do not take vector addition for superposition. So this is the case. So suppose this is the equation of the first wave, and here I have used omega 1t plus kx1. So omega 1 means that is they both may have same or different frequencies. So I have at first I have taken this is omega 1 and the second will be omega 2, and this is k is actually 2 pi by lambda. So 2 pi by lambda will be same for both the waves because they are coming from that monochromatic light. Monochromatic means if this is red, then this is also red. If this is blue, then this is also blue. So both are having same wavelength. That is our assumption. So the second wave will have the equation E2, that will also equal to E naught 2, and this is cos omega to t plus k x2. See, this has travelled a path x1 and this has travelled a path x2, and after that they are superposed. That's why here x1 and x2 are taken. Now, what will be the intensity of these waves? So if I write the intensity, so from my previous classes of EM wave, you can see suggestion at the top. So you can see that the intensity of any electromagnetic wave is given by this formula, epsilon naught E RMS square into C. So this is the intensity of any wave. Now E RMS square, so this is the average value. Average value means this is time average. So we do not take intensity that is instantaneous. So this is the time average value. So that's why RMS is coming. But here we have to calculate in terms of E naught. So that means the amplitude, the maximum possible value of the electric field. So if I take in terms of E naught, so this will be epsilon naught and this will be peak value by root 2. So RMS is peak value by root 2 square into C. So this will in turn give epsilon naught C by 2 and this square. So this E naught square. E naught is the amplitude. Now let us take this constant as beta and this is as A. So this assumption will make our calculation easier. So that's why I am assuming this. So where beta is equal to, beta is a constant which is actually epsilon naught C by 2 and E naught, that is the peak value, that is the amplitude, that is the peak value means E1 is actually varying but it is having a peak value. So like this is the peak value. So I have just drawn a little bit larger, but this is the peak value. So this peak value is actually E naught. So this E naught is equal to, I am writing it is A. So this will make our calculation easier. Okay, so in terms of this, so this is the intensity. So what are the intensities of individual waves? So we can write this wave. Okay, I am erasing this, now it is not required. Okay, so these two are the equations and this wave has intensity. So this wave has intensity, say I1. So this I1 is equal to, this will be beta and I am writing this as A1. So this will be beta A1 square and this wave will have intensity I2, that is equal to B2 beta A2 square. Okay, so this is the intensity of individual waves. So I am making a little short format of these two waves. So I can write it in this format that E1 is equal to, this is A1 because we have taken the amplitude as A. So this is for 1, for first wave, so A1 and this is cos and this will be omega 1 t plus k x1 and this will be E2 is equal to A2 cos, this will be omega 2 t plus k x2. So our assumptions are like that. So number one is intensity of first wave is this, intensity of second wave is this, and what is beta? Beta is equal to epsilon naught C by 2, and what is A1? A1 is actually the peak value of the first wave, that is the amplitude, and the second wave has E naught 2, this thing. And what is omega 1? Omega 1 is nothing but, so omega 1 is equal to 2 pi and frequency of 1, omega 2 is 2 pi and frequency of 2. What is k? K are same for both of them. So k is equal to 2 pi by lambda. So lambda are same because they are from the monochromatic source. This one. So one has travelled path x1, another has travelled path x2. So that is the difference, and only difference is in their frequencies. Now they are going to superpose. So now if they are going to superpose, we are interested to find what will be the intensity. So now see one thing, if I say what is the intensity of a electromagnetic wave, so there can be two results. There can be, I can say there is two results. One is instantaneous intensity, that means the intensity at present, just present now. And what is the average intensity? Time average, means in long run. So for EM wave, which is having a frequency 10 to the power 14 Hertz, so if we see in very minor scale also, say 100th of 1 second, then also it will give at a time average intensity. So that is called the average intensity. So we cannot write instantaneous intensity, but if I write instantaneous intensity, so I will write epsilon naught C and E square. So this will be the instantaneous. So I should write this instantaneous. This is the instantaneous intensity. But when I take time average, so time average, then we get the average intensity, then it comes epsilon naught C, and then it is ERMS square. Then it comes ERMS, that means the peak value by root 2 and the square of this. So this is the time average. But this is instantaneous. So at first you have to find out when they are superposed, what is their instantaneous intensity. So instantaneous intensity, so after superposition, instantaneous intensity will be simply epsilon naught C and E1 plus E2 whole square. So here we are not taking the vector sum, just writing E1 plus E2 whole square. Okay, so this will give epsilon naught C and E1 square plus E2 square plus 2 E1 E2. Okay, so multiplying with this, we will get epsilon naught C E1 square plus epsilon naught C E2 square plus epsilon naught C into 2 E1 E2. Now we have to write the value of E1 and the square of E1. So this will be epsilon naught C, and E1 square is actually your A1 square cos square omega 1 t plus phi 1. So this is the value of A1 cos omega 1 t plus phi 1. So I am writing this phi 1. So I am making another assumption here, because otherwise the calculation will be very large. So I am taking phi 1. So phi 1 is equal to actually kx1. So that is actually k is 2 pi by lambda, and this is x1. So similarly I will write the another equation E2. So this is equal to epsilon naught C, and this will be A2 square and cos square omega 2 t plus phi 2. So what is phi 2? I am taking phi 2 is this quantity kx2. So this is equal to 2 pi by lambda and x2. So this is actually k, value of k. So value of k in both the cases are same because our lambda are same, monochromatic source. So this one and the third quantity is there. So this is equal to plus epsilon naught C and 2 E1 is this thing. This will be A1 cos omega 1 t plus phi 1, and this will be A2 cos omega 2 t plus phi 2. So this thing is coming. So now we have to make it in a linear arrangement. Linear arrangement means whether I have to see it is a function of time or not. Like here cos square is present, so we have to make it linear, cos, either sine or cos in this format. So how it can be done? So if I do this epsilon naught C A1 square, and if I take by 2, so I can write this 2 cos square and omega 1 t plus phi 1. Similarly, if I take here epsilon naught C A2 square by 2, then I can write here 2 cos square omega 2 t plus phi 2. And here already a 2 present, so I have to take just epsilon naught C A1 A2 outside. So this A1 and this A2 outside, and the rest of the part is 2 cos A cos B. So 2 cos A cos B has formula cos A plus B. So A plus B will be this plus this. So this is omega 1 plus omega 2 into T plus phi 1 plus phi 2 plus cos omega 1 minus omega 2 into T plus phi 1 minus phi 2 bracket close. Okay, so see, this is cos A plus B. So actually this is your A and this is your B. So A plus B gives you, actually I have just taken omega same at the same in the form of time, omega 1 plus omega 2 whole into time, and phi 1 plus phi 2. So this, and cos A minus cos B. So this is omega 1 minus omega 2 into T, and this is phi 1 minus phi 2. So this thing is the total value. Now I am writing over it. Now 2 cos square theta, I am using this formula. 2 cos square theta is 1 plus cos 2 theta. So this instantaneous value will be, epsilon naught c a1 square by 2, and this will be 1 plus cos 2 theta. So this is 2 omega 1 t plus phi 1. So this one, second component epsilon naught c a2 square by 2, this will be 1 plus cos 2 omega 2 t plus phi 2. And the third part, so third part is this one. So this is epsilon naught c a1 a2, and this is a long term, okay, no problem. So this is cos omega 1 plus omega 2 into time plus phi 1 plus phi 2, and plus another part is there. So this is cos omega 1 minus omega 2 into time plus phi 1 minus phi 2 bracket close. So this is our terms that we are getting. Now this is the instantaneous value. Now there may be two cases. So there will be two cases. Now this was the instantaneous intensity, but we are interested in average intensity. That means time average intensity. So when we say about time average intensity, then suppose all these functions of cos, and within the cos there is the function of time. So they will give a continuous curve like this. So suppose this will be the curve. So if I take the curve of cosine, and this is a function of time, so there will be a long curve like that, because it is associated with time. So cos of something, so that will give many cycles, and all these positive halves will be cancelled by this negative half. This is positive half, this is negative half. Cancelled, again this positive half, again this negative half. So positive and negative cancelled. So similar way, this is negative and this is positive. So positive, negative, cancelled. So the summation of all these, so when they are within the time, so time average of all cos of any time average, cos of sine of any time average, so that gives actually 0. That means it should be in the format of cos of something, say theta, where theta is a function of time. So the average of this will be equal to 0. Or if you say sine, so sine of anything which is a function of time, so its average will be 0. So this function, this theta should be a function of time. So here you can see, here is a function of time is there, here is a function of time, this is also a function of time, this is also a function of time. Now what can be done? So now there can be two cases. One is called the coherent source. Coherent source means when we say omega 1 is equal to omega 2. So omega 1 is equal to omega 2 means this is equal to 2 pi f1, that is equal to 2 pi f2. So in turn this means f1 is equal to f2. So both are having same frequency. We have just considered monochromatic light, they have same lambda, but we have not considered they are having same frequencies. Now if they are having both frequencies, both the sources having same frequencies, so this condition is called coherent source. So these sources are called coherent sources. So if they are coherent sources, so then okay, my time average, so for coherent sources, so this is the condition. So for coherent sources, what we will get, that the time average, so time average is generally given by, so this sort of bracket, so this is the time average. So the time average of this will be 0, and also this is also a function of time, so time average of this will be 0, and the time average of this is also a function of time, so this will give 0, and this is also, so cos of this, so I should take from the cos, okay, so this, and the time average of this. But will it give 0? No, it will not give 0, because now omega 1 is equal to omega 2. If omega 1 is equal to omega 2, that means this parameter, the time parameter, has gone. When the time parameter has gone, then there is only phi 1 minus phi 2. So this thing will remain. So this thing will remain. So for coherent source, we are getting this result. That then this is called I average. I average means this is the time average. So you will have only this. So this is epsilon naught c by 2 a1 square plus epsilon naught c by 2 a2 square plus this thing. So this is epsilon naught c a1 a2 and cos of, so this part is 0 because omega 1 is equal to omega 2. So you are having only this part. So cos phi 1 minus phi 2. So this part will be present. So this can be written as, remember we have considered this as beta. So this is beta a1 square plus this is beta a2 square plus, how can it be modified? Okay, you can take 1, 2 and you can write root under epsilon naught c a1 square by 2 and then again root under epsilon naught c a2 square by 2 and then cos phi 1 minus phi 2. Now see, if I make the product, then it will be epsilon naught c and this will be a1 a2 and by 2 and 2 is cancelled. So this thing is again, you can write this is equal to beta a1 square plus beta a2 square plus 2 root under beta a1 square root under beta a2 square and cos phi 1 minus phi 2. So remember that we have taken I1 is equal to beta a1 square and I2 is equal to beta a2 square, where beta is equal to epsilon naught c by 2 that we have considered earlier. So that means this is the intensity of one wave, this is the intensity of another wave plus 2, so this is the intensity and root under intensity. So this will be root I1 and this will be root under I2 and this will be cos phi 1 minus phi 2. So this is the case when the sources are coherent. So then we are getting I1 plus I2 plus 2 root under I1 I2 cos phi 1 minus phi 2. So as a whole this phi 1 minus phi 2 is called, what is phi 1 minus phi 2? What we have taken basically. So if I write this, this will be I1 plus I2 plus 2 root under, you can write this I1 I2 and this can be written as C cos of, so phi 1, what we have considered phi 1, so phi 1 is equal to actually kx1 So this is equal to 2 pi by lambda and x1, and this phi 2 is equal to kx2, which is equal to 2 pi by lambda into x2. So we already had considered those things. So if I take 2 pi by lambda common from here, so this will be 2 pi by lambda, this will be x1 minus x2. So ultimately we are getting this relation. If the sources are coherent and monochromatic, then the relation is this. Now x1 minus x2, this is called the path difference, that I will be discussed in my next class. So, and phi 1 minus phi 2, this is called angular phase difference. So this is one case when omega 1 equal to omega 2. But suppose if omega 1 is not equal to omega 2, second case. So that means the frequencies are not equal. So then they are called incoherent sources. Incoherent sources. So if they are incoherent sources, then the time average of this is 0, gone. Time average of this 0. Time average of this is 0. And time average of this, so there will be some part will be remaining, which is multiplied by time, because here omega 1 is not equal to omega 2. Omega 1 not equal to omega 2, so some part of this will remain. So when there is some time is involved, and as this is EM wave, so having very high frequency, so within that small span of time, it will have an average, and that average will leads to 0. So in that case, for incoherent self source, we will not get this parameter. We will get here plus a 0. So this will be the case only. So for incoherent source, we will get this. So this is our beta A1 square, and this will be only beta A2 square. So this is our intensity of 1 plus intensity of 2. That means it can be seen that if the sources are having not the same frequencies, they are having different frequencies, then you are not getting any gain in intensity. You are just getting I1 plus I2. But if there is omega 1 is equal to omega 2, that means if they are coherent, then there can be some chances. That means a cos parameter is there. Cos of phi 1 minus phi 2 is there. Now this cos phi 1 minus phi 2 may be 0, or it may be minus 1. So depending on that, you will have either constructive interference or destructive interference. That will be discussed in my next class.